So for the mini project, I choose to test an application allowing its user to play rock, paper, scissors with artificial intelligence. Initially, we have to import the necessary libraries, namely TensorFlow and scikit-learn. Although the code did come with an already trained model, it is best that we retrain it using our own dataset, since the author's hands differs in various ways compared to my hands. To do that, we have this piece of code with the function gatherData. It allows us to capture a desired number of samples per hand signs, that is for rock, paper, scissors, and nothing, where nothing represents no hand sign at all. So we have 4 arrays to hold the samples for the 4 classes of hand signs. Note that our footage is captured from a phone's camera. We have a variable trigger, which basically starts capturing hand signs when a key is pressed. The possible keys to cause this trigger are R for rock, P for paper, S for scissors, and N for nothing. Next, we define the size of our region of interest. That is the region where we wish to capture our samples. Its size is actually 224, and the model used here is NASNETMobile, which is actually suited for image of size 224. Thus later on there is no need to resize the sample images. But here we added 5 additional pixels to each side of the region to allow the user more space to capture his hands. Thus 234. We also drew a rectangle on the frames to guide the user. If a triggering key is pressed, we start capturing at our region of interest. So here we can see the keys to press for each class and their corresponding array. For this demo, we captured 100 samples for each of the 4 classes. So we have 400 images in total. We may then visualize 8 random images from each class. Next, we have to prepare our dataset for training. So we combine all the labels and all the images collected respectively, and we separate our dataset into 2 parts. 75% is used for training and 25% is used for testing. Then we prepare the model itself. Here we can see that the necessary additional layers are added to the base NASNETmobile model, which leads to the final layer containing 4 nodes corresponding to our 4 classes of hand signs. A dropout layer and a global average pooling layer are also included to avoid overfitting. Finally, we train our model for the desired epochs with a desired batch size value. For demonstration purposes, we use 5 epochs here and a batch size of 25. However, the final model used in this application was trained for 15 epochs with a batch size of 30. We will also plot an accuracy and loss graph to observe convergence. If we are satisfied, we may then save and load the model. However, before building the final application, we will test the model first. This code is similar to capturing data, except here the region of interest is constantly checked by the model to predict which hand sign is being presented to it. We can also see the confidence of the prediction. Next, we move on to building the final application. To do that, we first have to define three helper functions first. One is to find the winner. So for example, rock beats scissors, or paper beats rock, and so forth. The second function is to show who won. So if we are playing a best of 3 and the computer wins at least 2 rounds, then this function shows that the computer won. The last and final function is to display a small graphic image for whichever move the computer randomly chooses to play. Lastly, we build our final application. Here we can set how many rounds we want to play. Again, we have our region of interest, which is constantly monitored. So the computer plays a move as soon as the model detects a hand sign other than nothing in the region of interest. Note that we have set a confidence threshold of 70% against which the prediction made by the model is tested. If the prediction made has a confidence of over 70%, the computer then plays a move. We use the helper function defined previously to display a small icon for the computer's move. We also use the other helper function defined previously to see who won the round. We also decrease the number of rounds by 1 until it reaches 0, and by then we use the final helper function to show who won the game. Lastly, some modifications were made so that the application is better suited for mobile camera and for first-person view. And that about concludes this mini project. Thank you.